Hello everybody and welcome back to Operation Logistics, where we just created a bunch of new intersection types, and we need to be assigning and rotating our intersection types. But as usual, assignment will be first. So the first thing we need to look at, I think, is going to be what type of intersection do we need? And for that, we're going to need to add a few more prefabs to our script for our sub-hex manager up here, because we need a few different types of road intersections now. So public game object, road junction, road intersection Y, road intersection E. Okay, so we'll add those to our sub-hex manager as soon as it compiles that. There we go. So we need our road junction, which is, I think, this one. Nope, that's road corner sharp. Road junction is actually this one. Okay, road intersection Y, which I believe is this one. And then road intersection E, which it's kind of hard to tell, but I think is this one. That's two-way. That's E. Okay. So we have those in now. So let's go to our logic for where we are creating our road intersections. So realistically, our intersections are down here. We know that if our intersection count equals 3, well, actually, this is a really bad way to do it. So realistically, I think for right now, let's just say spawn road equals true, road equals road intersection two-way, and let's get rid of everything here, because I think that was a really, really naive way to go about it. So let's go ahead and just start over on the intersections. So if there's an intersection, all it does right now is it just spawns a two-way intersection by default, which isn't necessarily what we want it to do. So what information do we have on the intersections? Well, we know for a fact what roads pass through the intersection, and I'll show that to you here. So let's look, for example, at this intersection here, a standard two-way intersection, and it actually chose correctly by sheer happenstance. So this is the hex here that spawns the road, and we know the neighbors of the hex, and we know what roads go through here. So that's interesting. We can use that information to determine what type of intersection we need to be and what type of rotation we need to be at. And I can close Blender here. We don't need that open anymore. So let's go ahead and say, how do we know that it's going to be, say, a junction? Well, let's go ahead and comment this out. And let's do a two-way intersection first, actually. So, first things first. We know it's an intersection, and that means that we know it's on at least two roads. So let's take stock of our neighbors first. And if our neighbors are on a road that is inside of our list in our intersection, then we know that that's a direction that we're going in. So let's go ahead and create a list here. So list, and this is going to be a list of sub-hexes. And this is going to be connected neighbors. Okay. And we'll go ahead and make this be a new list sub-hex. And the first thing we're going to need to do is we're going to need to determine which of our neighbors are actually connected to us. So let's go ahead and say for int I equals 0, I is less than, I is less than neighbors, and actually we need to do sub-hex, actually, and I is already taken, so sub-hexes i.neighbors.count I++, except we need to do j, not k. K would work, but we'll do j. So j is less than subhexes i.neighbors.count, j++. So we need to iterate through our neighbor list, and we need to say if subhexes i.neighbors j dot... How do I want to do this? Actually, over this way, I want to say if... Can I access our road from here? If our road subhexes i dot on road dot contains neighbors j dot on road, that would be the easy way to do it. It's kind of complicated, but I don't think we have access to our road from here. Yeah, that's only if buildings, if we're equal to this. So let's go ahead and say, let's go ahead and do this. So if we're down here in the intersections, we're going to need to get a list of roads. So let's go ahead and say our road equals roads subhexes I dot on road. So if our road subhexes I dot on road dot contains... Actually, we don't want our road dot subhexes I dot on road. We want... And this still might be necessary. No, I don't think it is. I'm going to comment that out. Instead of doing it this way, I want to do it a different way. I want to do it if subhexes dot intersections, or actually subhexes I dot intersections dot contains subhexes I dot neighbors j dot on road. Then we know that this is a connected neighbor. So connected neighbors dot add subhexes I dot neighbors j. Okay, that might be a little bit confusing. So what's happening here is we iterate through our list of neighbors, and if our neighbors are on a road that is contained within our list of intersections, then we add them to a list of connected neighbors. So now we know every neighbor that our intersection connects to, theoretically. Now, one thing we might want to say is if subhexes I dot neighbors j dot building equals buildings dot road, or subhexes I dot neighbors j dot buildings dot building equals buildings dot intersection. So if that's true, and the following is true, and we need a parenthetical here. There we go. Okay, so if it's a road or intersection, and that is one of the roads that is part of our intersection, then we add that to our connected neighbors. So we now have a list of our connected neighbors, and what can we do with that? Well, I suppose the other thing we could do is make sure that we don't have any doubles. So let's go ahead and say and not connected neighbors dot contains subhexes I dot neighbors j. Okay, now we definitely won't have any doubles. I think we need a new parenthetical there. Yes, we do. Excellent. Okay, so now we definitely don't have any doubles in that, and it definitely is connected to us. So with that, we can determine, to some degree, what type of intersection we need. For example, if connected neighbors dot count equals 6. So if there are 6 in there, then we need to say this is definitely a three-way intersection. So road equals road intersection three-way. rot equals vector3.0. Okay. Yes. We need a semicolon there. So rot equals vector3.0. We know it's a road intersection three-way, and because it's going all directions, we don't need to rotate it at all. So if connected neighbors.count equals 6, we're done. Otherwise, let's have our prefab for building road. Come on. Placeholder. Yeah, that's what I called it. Do we have that in our subhexes? Yes, we do. Okay, so up here, road equals road placeholder. There. So now we know that we'll be spawning a placeholder road, unless it's a three-way intersection, which we have very few of those, realistically. So then if the number is 5, then we don't actually have a way to handle it. So there's that. If, and actually this can be an else if connected neighbors.count equals 5. I suppose we could do this in a switch statement. It would probably be a little bit cleaner. Let's go ahead and do that. So let's say switch connected neighbors.count case 6. And then I'm going to indent this and break. And then case 5, road equals, well, actually in case 5, we'll just let it do a default placeholder. So we'll just debug.log 5-way intersection. I'm confused because we don't have a way for it to handle that yet. So we'll go ahead and break that. And then we will do a case 4. In the case of a 4, this will be more in depth. This will be more in depth. We need to determine if this is a Y or an X intersection. Y, E, or X intersection. Actually, Y is a three-way, so that's if this is an E or X intersection for case 4. So for right now, we will simply debug.log 4-way intersection not implemented yet. And break. For case 3, this will be more in depth. We need to determine if this is a, and I guess we could say it's kind of a T intersection. If this is a, essentially we're saying Y or a straight up and down. Well, that's more of a junction. A Y or junction intersection. And then case 2. And actually we need a break statement here. There we go. Case 2, break debug.log 2 isn't an intersection at all. This shouldn't happen. And then case 1. Debug.log. No, please. This is not even a road, let alone an intersection. And break. And rather than doing case 1, I think I'm just going to go ahead and make this be a default. There we go. So if it's 0 or 1, it's not even a road, let alone an intersection. If it's 2, that's not an intersection. If it's 3, we'll need to determine if it's a Y or a junction. If it's a 4, we'll need to determine if it's an E or an X. If it's a 5, instead of saying I'm confused, let's just say we don't have a mesh for that yet. I mean, we could make one. But let's just see how this works. It's not going to do anything particularly special yet, but we have the tools in place now to be able to actually do this. So there is a 5-way intersection here, apparently. That's intriguing. Where is it coming from? Let's see. 1, 2, 3, or rather 1, 2, 3. It's interesting. So where is this 5-way intersection? It looks like here would be the most likely location, but I only see 3 connected. 2 isn't an intersection at all. This shouldn't happen. I'm wondering if I'm counting it wrong. And that these are actually 3. This is a 5, and this is a 6. We actually have 2 5-ways there, according to that. Let's take a quick look here. Neighbors.count is going to be 1 indexed. So if there's 1 there, it will return 1 rather than 0. So 2 isn't an intersection at all. Let's see what happens with a +1. I'm not sure exactly what'll happen there. We'll find out. Okay, so we have a 4-way intersection here. 1, 2, 3. We have a 4-way intersection here and here. Maybe. We also have a 5-way intersection. I don't know. What's going on here? Are we counting this wrong in some way? Okay, these are 6-way intersections, allegedly. But it actually isn't. Oh, I know what the problem here is. This is on the same road, but it's not actually connected. Uh-huh. Okay, we're gonna need to do this slightly differently then. So I think what we need to do is we need to go into sub-hex, and we need to say something along the lines of public sub-hex next road piece, and public sub-hex previous road piece. Okay, and now we need to set those, and we need to know what our next road piece is, because we need to know if it actually connects. That's what we need to know right now. So in the sub-hex manager, when we actually create the road types, so when we do our building positioning here, we need to say that previous position equals. Okay. So we're generating our roads here. We can get rid of this commented line. We need to say current hex.onRoad, that's fine. We need to have our previous and our next positions being assigned here. So then the question is, when we change our current hex, let's go ahead and do a sub-hex next hex. We're not going to assign that quite yet, but we'll say next hex equals possible locations, next hex dot previous road piece equals current hex dot next road piece equals next hex, and then finally current hex equals next hex. So that will work fine, but for road entries, for the final locations in the road, we can't assume that those are assigned. They will probably be null. But for everything else, it will know what its current and next hex, or what its previous and next hex is at this point. So, down here, when we are doing our intersections at this point, we only need to add, instead of checking to see if they're on road, we only need to check to see if, and I'm going to have this be in a parenthetical, if subhexes I dot neighbors j, nope, dot neighbors j, and how is this going to work for intersections? Well, it's kind of not. We can't assume that intersections have this in place, because it's probably going to get overwritten. But for non-intersection pieces, it'll be fine. That said, intersections can be right next to each other, which is a potential issue. In fact, it's going to be an issue. How am I going to handle that, then? I think just for right now, it won't consider intersections as incoming. This is bad. Fix this. Okay, we'll fix that at a later time, because it's just going to break everything. But for right now, we need to say, and subhexes I dot neighbors j dot next road piece equals subhexes I, or copy this whole thing right here. Oh, come on. There we go. Copy this whole thing and say, instead of next road piece, previous road piece. And it's not already on the list. Okay. So this is not going to count it if it is an intersection. However, it will count it if it actually connects and isn't an intersection. That said, I think we need to have not count +1 there. There we go. So now we know if it's actually connected to us or not, unless it's an intersection. If it's an intersection, it gets a little confused. In fact, it seems to just kind of generally get confused right now. So, with that being the case, looking at this, something is clearly horribly wrong. Because this should be a 3-way intersection, but it appears to be thinking it's a 2-way intersection. And then our one 3-way, or rather our one... Yeah, it's very confused at this point. So, I mean, we can go ahead and have this also be buildings.intersection, but we need to realize that if this is... It will be overwritten when it goes through again. So maybe what we need to be doing I have an idea. What if we call this next road pieces and previous road pieces and make this be a list of subhexes? Now, we can assume that there's nothing, that there's only one in the list for non-intersections. But we can't assume that for intersections. And then, yeah, I know there's going to be issues here. So next hex dot previous road pieces dot add current hex. And then here, current hex dot next road pieces dot add next hex. Now, one thing we should definitely do, we should absolutely do, is down here where we are clearing hexes, we need to make sure that we do subhexes I dot next road pieces dot clear subhexes not oi I dot previous road pieces dot clear. We need to make sure that that's cleared. Okay, so with that being cleared, we can then come up here and we can say we can split this into two separate if statements. So we can go ahead and split out the intersection. So if it's a road, next road pieces 0 equals subhexes I, previous road pieces 0 equals subhexes I. I'm going to go ahead and bring that down onto another line. And it's not already on the list. Else, if, and then basically we copy this whole thing, like so, paste it here, and then if it is an intersection, and instead of doing this one, if next road pieces dot contains. Although we could combine those back together, couldn't we? I think we could. Or subhexes I dot neighbors j dot building equals buildings dot intersection. So if that's true, then instead of doing it this way, we can just simply say next road pieces dot contains subhexes I, or if I can get my parenthesis done there, or down here, previous road pieces dot contains subhexes I. Like that. Maybe that'll work better. Let's find out. I think it will. It might be a little slower to generate, but it shouldn't be too bad. Four-way intersection not implemented yet. So this is really a three-way intersection here with a kind of lambda signal. This is a four-way, definitely. But this is an E intersection. This one here is more of a junction. No, this is a lambda. Well, a lambda is a junction. So yeah, this is a lambda here. This one here looks to me like it is a T, which I don't think we have implemented. Actually, maybe we do. I mean, it's actually just a junction. So that's a junction there. That's a three-way. This one is a four-way, for sure. And this one here is a junction as well. But interestingly, it only output these. It only output 3 rather than outputting the 5 that are there. So what did we not do debug.logs for? We didn't do one for a three-way intersection. So let's go ahead and do one for here. Three-way intersection not implemented yet. And then six-way intersection should be the only one that doesn't actually output. Let's see how that works. It seemed to be working largely fine. Okay, so we have 5 here. We have 5. That's good. This is a junction. So that's a three-way. This is a junction as well. That's a three-way. This is a trident, or I guess I'm calling it an E. This is an E intersection, so that's a four-way. This one here is a junction, so that's a three-way. So that's 3 when we only have 2 listed. And then this one is also a junction. So I think we're getting too many in some of these, but it's mostly working. We can work on ironing those out even, in the next episode, because it is time for me to put a cut in here. So I think I'm going to go ahead and do that, and next episode, we will work on getting these intersections a little bit more ironed out. See you all then.